This is Campbell Road. There's Lila and Finn keeping us company. So I want you to imagine we're now a glucose molecule, we're turning into Campbell Road. Looking at the concepts that we learned throughout this lecture series, this road has a downhill descent all the way to the roundabout. This is what glucose is doing. So you imagine all the cars in front of us and behind us are glucose molecules, and as we're going down we're getting broken down into other intermediates. Do you see these side streets here? What's happening here is that things shunt in and out of glycolysis to make stuff if the cell needs to. Otherwise it just goes straight down. Oh, here's an irreversible step. That's hexokinase. Finn, Lila? Sorted? Good. So we're past the point of no return. We're coming up to a roundabout here called Onehunga Mall. You can think of this as another irreversible step, I guess. See, we're going down a downhill decline here. So phosphofructokinase is the second irreversible step. So that's regulated by things like ATP. Watch this car. So when ATP is high, the enzyme is inhibited. We don't want glycolysis to proceed. Here we go, a bit further down. Getting all these little dips. Here's a little dip here. So these are like little free energy changes. Well, this is actually probably a bit more than a bigger dip, little dip. This is probably a big dip. This is almost pyruvate kinase, although that's almost towards the end. So that's the third irreversible step, pyruvate kinase. So now we're a pyruvate molecule. So we've come to the end of glycolysis. Now the cell can actually, if it needs to, bypass glycolysis, those three irreversible steps. But what we're doing is we're a pyruvate molecule at the moment, and we're going down to the roundabout in front of me. And that roundabout has got 5 metabolic fates. And what we're going to do, we're going to choose one of them. One of them is the alcoholic fermentation. So we're going to cover that. That's where the pyruvate is converted to ethanol. The reason for that is that the cell needs NAD to keep glycolysis going. So we've got all these other little pyruvate molecules here, all interconverting into each other. Could be alanine, lactate, aerobic respiration. Here we go, round the roundabout. But we're doing the alcoholic route. And the reason we're doing an alcoholic route is because there's a pub here, and it's called the Zookeeper's Inn. So that's a perfectly appropriate route for alcoholic fermentations. There's a few people outside enjoying their Sunday afternoon. So that's glycolysis there for you. Hopefully you remember that in 10 years when you're doing whatever you're doing. So we're just going to park here and we're going to stop the video. Bye.